This call is now being recorded.
Good evening, guys. I hope you are all doing great. I think, Irene, please make sure your mic is muted because I heard something from your side there. And then, yeah, I hope all of you guys are doing well. Uh, Let us start with today's lesson. So, today we'll just cover mostly only examples actually. Starting with the homework that I gave you guys, which let me see. So basically, what this means is we have covered all the fundamental theory or notes that you need in order to understand vectors, and then that's it. Mm. Yeah, this is the homework I gave you. So um, I think someone asked me about the method of was this determining a vector's direction using a bearings. If you are in this call, just let me know if you still need an explanation on that. So now, yeah, I gave you guys this homework, and then it's a straightforward homework actually. If you follow every principle that I showed you when it comes to resolving vectors, and then moving from there to adding these vectors, and then finally to getting your resultant vector in its direction, okay? So the steps are always the same. Nothing pretty much changes. You just have vectors that are in 2D. Usually you'll be given the angle. If it's not given, you'll have to sort of do your maths there to find that angle. And then from there, you can take out the components. Once you take out the components, you add them respectively. You start with the x components or the y, depends which one you prefer. Let's say you start with the x. So you start adding up all the x components. That's your rx. And then you go ahead and add your y components. That's your ry. And from there, you use Pythagoras theorem from the ry and rx values to find now the final net force, so the final resultant vector. Because it can be anything, can be displacement, can be anything. So with this one, we will just we might skip some steps because I've shown you this thing several times now. So let's start with reading this thing. What is it saying? Three forces P, Q, and R of magnitudes 400, 250, and 300 newtons respectively. Yeah, but I'm sure you guys know what respectively means. It just means this order in which they mention these forces is the same order in which they mentioned these vectors P, Q, and R. So if someone says you and your friend went to a shop and one bought snacks and the other bought, I don't know, whatever else, respectively, it just means in that order. Okay. So, yeah, I think you guys should know that. Let's see. Let's take out the components of all these vectors, starting with the P vector or the 400 Newton vector, right? Let's start with the Y components of all of these vectors. So you have Y here. By the way, you don't always have to use my annotation. You see, I like saying FP, then adding a Y to show that it's the Y component of force P or of vector P. You don't always have to do that. Actually, it's not always forces. Let me see. Oh, yeah, in this case, these are forces. It's fine. So sometimes what you can do, I'll show you now, which is probably what you are taught in class. And then let's do Q. So let me call this FPY. And this would be FQY, right? This thing is a bit too thick. Let me see. Can't even see proper. F P Y. Okay, much better. F Q Y. All right, so we have these components. Let's go to R. R is where, okay? You just draw a line to your Y component, to your Y axis. And from there, you draw a line from the tail of that vector until you reach that construction line that you drew. Then that would be your Y component, right? So this is what? F, R, Y. So I took this question paper from this website that you see in the background. It's done more physics, I think that's how you pronounce it. So if you want more of these, you can go there. They have quite a number of question papers. You can just download them. Yeah, I think they also have memos as well. So now you have that. Let's find the axes now. Axes. The mathematical ones, not other axes. Now let's see. Yeah, this one. This is F. FPX, right? Oh, this looks ugly. FPX. All right, so then you come to Q. You draw a line until you reach Q. You come to the tail of Q. Draw your other component. So one thing I need to remind you guys is whatever I'm just doing here, it has no marks in the exam. So the reason I keep doing it over and over again is so that in your mind, whenever you see these vectors, you know that this is how you resolve them into their own components. Then you can start calculating. But in actual fact, in an exam, you don't have to draw all of these things. You can just draw them in your rough, wherever you do your rough work, so that you know that, okay, this is where they're facing. This is how I'll add them up once I start working them out, okay? There's no marks for it. It's just for your own thought process to make sure that you have every step and then you're not getting anything wrong. So once you are in the habit of doing it, at some point you don't even have to draw them. Once you practice enough, you can just look at the angles and you know what to do. Right. So yeah, we have all our components now. This is F, R, X. Okay. So we can start adding them. But before we do any of that, obviously we have to make sure we follow what our questions are saying. So 2.1 is saying define the term resultant vector. Okay. Excuse. So if you remember what we said about resultant vector, I said for every definition that is in a physics or whatever other paper that you might write in your high school, it's as simple as before that exam, always make sure you know all of your definition. You simply list them down and you memorize them. That's the quickest hack, especially if you're into calculations too much. Okay. So now, who cares to define for us a resultant vector? What's a resultant vector? I think I gave you the definition on our previous lesson. It's the same definition you can use in your exam. It is completely acceptable. So what's a resultant vector, guys? Okay. You guys are oddly quiet.
A, a resultant vector is a single vector having the same effect as two or more vectors together.
Yes, that's true. Thank you. So it's basically a vector that has the same effect as two or more other vectors combined. So it's the same idea we've been doing here. You have 1, 2, 3 vectors, P, Q, and R. When we find the resultant, what we are saying is that magnitude and direction of that resultant is a representation of PQ and R. It's basically if you can call it a summarized form of PQ and R. A resultant is just that, right? It tells us in summary what's happening here in this whole diagram. Because you can see there's a lot of vectors, but then what we do is we take everything and we turn it into one thing instead of having all of this noise. So that's what essentially a resultant vector does, okay? So I won't write the definition. You should memorize it there from your notes. But let's get into the calculations, which I think carry more. Okay, I've already written the definition in our previous notes, but it's fine. Let's write it again. A single vector that has or having the same effect. I think they say having the same effect as two or more vectors combined. Right, so that's what a vector resultant vector is. So now, okay, in this example or in this question, we were told to first do the horizontal components of the forces acting at O, and then come back and do the vector sum of the vertical components. So they broke it down for us in this case. We didn't have to do it ourselves. Lucky. Or luckily. So now 2.2.1. They asked us for the horizontal vectors or the x components. So this means we will have Rx, like what we've been doing before. Rx is the sum of our, remember, before we even do that, let's choose a direction. Say I choose to the right as my positive, right? It's the same thing we've just been doing. So if you check in other textbooks or depends, even your teachers as well, some prefer to write this summation sign. You won't get penalized if you don't write it though. So some will say sum of Rx like this. So I just leave it out because you don't get penalized nonetheless. So if you're into that, you can always write it here. It's okay. So now Rx is all the x components of these different vectors. The x component of P, the x component of Q, and the x component of R. Let's do it fast. So you'll have FP x plus FQ x. Keeping directions in mind, FR is obviously opposite to P and Q. Okay, I didn't write this one. This is just FQX. So if you notice, FPX, FQX are both going to the right. So those are positive. Only FRX is going to the left. So we'll have to add it as a negative because we chose to the right as positive. So we'll have to say plus, then we add minus FRX. Now, we convert all of them into their so FPX is, if you check the triangle there, you have something like this. You have that. Then 20 somewhere here. Ne? Then you have FPY and FPX there. Then there's just FPOP. So yeah, that's what we have. So now we're looking for FPX. Obviously, it's opposite to our angle 20. So we'll use sine 20. So we'll have FP sine 20 degrees, right? Plus, I won't draw all of these things like I did last time because I've already given you a detailed breakdown of how to get these trig ratio relations. Okay, so if you wanna check out how we did that, you can always go back to the previous notes or our video that we did last time. And then FQX. Oh, see, FQX is like this. We have our theta here, and we have FQX, and we have FQY, then there's FQ here. So we're looking for FQX. It's on the side where theta is sitting. Theta is sitting on top of that side. So we use adjacent, which is cos. It's on the adjacent side of theta. So we'll say FQ cos theta. But what is theta? Theta is as simply as saying 90 minus 20 minus 40 degrees. I hope you all understand how I did that. If not, please ask now before I continue. So that's our theta. So this should be 60. So this is 30. Is it? Yeah. So we'll convert this to just 30 degrees. We substitute here 30. Are you guys comfortable with how I found this theta? It's just simple geometry there. And then, oh, this one is a minus. FRX. Is someone saying something? Okay, I thought someone was talking. Okay, so FRX, if you check FR, we have a triangle like this, right? Never mind my lines, they are not straight, I know. Just imagine them as straight lines. I'm sure your imagination won't betray you. So now we're 50. Okay, this is disturbing. Yeah, much better. Now 50, and then we have FRX, FRY, and then just FR here. Some people might say RX, R here, and RY there. I don't do this because I use my RXs when I sum everything up, so I don't want to get confused. So that's why I stick to the FRs and so on. So we're looking for the adjacent side of this triangle because it's a right angle triangle. It's always a right angle triangle. And then one thing I want you guys to remember, these things, these trig ratio relations, they are not always the same, right? So if, for instance, I think I told you this, if I have 30 here and I have A, B, C, sine 30, right, just something fast is A over B, right? But if now I have the same triangle and maybe 30 is now here, but nothing has changed here, A, B, C. Check now that sine 30 is now C over B, you see? So never just think, oh, whenever I'm looking for the horizontal component, it's always going to be a cos. Oh, whenever I'm looking for a vertical component, it's always going to be a sine. That is a huge mistake. Never make that mistake. Okay, it will never be the same. It changes depending on where the angle is located. Right, that's something I wanted to make sure you guys understand. But I think I told you before. So now FRX will be cos. It's FR cos. FR cos 50 degrees. So now we can substitute FP. It's just 400 sine 20 plus FQ 250 cos 30 minus, what was this one? 300 cos 50 degrees. Yes, you'll get your answer. Yes?
Sir, I'm sorry for the disturbance, but can you at least start over from 2.2.1? I didn't actually understand it.
You're saying I should start over from 2.2.1, you don't get it?
Yes.
Okay, no stress. So you want me to break down? Oh, Temba is also, your hand is up. Yes, Temba.
So say I wanna ask if I already, because what I've done, I said fp of x is equals to 400 cos 20, and then I got the answer of 375,88. Am I right or wrong?
That's
I
not.
didn't add them. I only substitute 400 on cos 20 degrees. Then I multiplied them and then got the answer.
I'm not sure if I get you. So you're saying here, you just went straight here. You didn't do this stage.
Yes, I did that. Then I got the answer of 375,88. I only did that when I got the I when I after I mean like after I got the answer, I then added them and got a certain answer.
Oh, you're saying for every. Oh, okay, I see. So what you're saying is you would get the answer for each of them and then add them at the end.
Yes.
Oh, that's still fine. It's just that you will likely get an answer that is. So let's say, for instance, in a memo or whatever. Oh, okay. Actually, let's compare you and I. Let's say I get what's this? Let's say I get 66.53. In your case, you would get 66, maybe point 4. Oh, actually, let's say 0.79, something like that. Oh no, this is too high. Let's say 0.58. So usually the decimals will be a bit off, but it's still correct. That's
Oh,
something yeah, because usually when you do it like that, you keep rounding off, so the accuracy of your answer will keep changing. But if you
oh,
just substitute at the end and then find the answer, you are more likely to be more accurate like that.
oh, thank you.
Yes, it's also something that's done in chemistry. If you do chemistry, they'll tell you that don't round off until you reach the final answer. I think you keep 4 decimals if I'm not mistaken. So, yeah, but it's still fine. And then let's explain to someone asked if I can start from here. Um, so let's start with. So what I want you to understand here, ne, when we are breaking down this thing. So let's start with P, for instance. P is like this, right? Uh, that is the vector P, and it has an angle here of 20. There's this angle here, 20, right?
Yes. So, sir, why can't we use the 40 degrees?
Oh, 40 degrees, we can't use it because it is not, it's like this. It's not measured from, what's this?
The
A proper
x-axis.
reference. Yes, it's not measured from the X or the Y. It's just between vector P and vector Q. So you can't use it. You can't, it's just like saying the difference or the distance between P and Q. It's not
Okay.
useful for the components. What you are looking for is an angle that is measured relative to something straight. Like for instance, that's the simplest way I can sort of explain it to you. It must be measured relative to something straight, not something that's what's this, diagonal, or let me just. So if you check this line is not really going either down or to the left like this. So we can't really rely on it for taking out the components of either P or Q. So it has to be either measured from X or from Y. So if maybe there's a line here, its angle must be measured from here, right? Or from there. Then we can use it to find the components of that vector. But if now there's another vector like this, and I measure the angle here, I can't use that angle is very useless to me. So it is only useful because it helped us to find theta in this case. If you remember, we just had to subtract it from 90 so that we could find theta. So yeah, do you get that part?
Yes, I did.
So was that your only confusion? Or you want?
Yes.
Oh, okay. So but you get these ones, how we get the courses and so on.
I'm also surprised. How did you get to add them?
To add.
Yes.
Oh, so remember at this stage they told us here that what is the vector sum, right? Sum is adding, obviously, of all the horizontal components of the forces acting at O. So we are told that we need to add all the horizontal components at point O. So what that means is we take all these guys. There's FPX, which is the horizontal component of P. There's FRX, which is a horizontal component of R. Then there's FQX, which is a horizontal component of Q. So if you like to think about it this way, these are basically like terms. Why? Because they are all horizontal components. So they are all along the x-axis. So it's easy for us to just add them. So in a sense, they are collinear. So if you check when we're resolving these vectors here, check this thing here. These guys, they are all within one straight line. So it's possible to add them together. So yeah, but as per our instruction, we were told to just find the vector sum of these things. So we didn't just come up with it on our own. But
Yeah, get it.
then, yes, but then also, if we were not told, it's one step that we have to do whenever we we want to find the overall resultant vector of all these forces. So what that means is a resultant vector will have, it's actually in the definition if you think about it. Let's say this is the resultant vector we were looking for. It will also have its own R, okay, what's it? Its own horizontal, vertical, okay, this thing is misbehaving, and horizontal components, okay? A resultant vector that is 2D. Yeah, let me specify it like, let me remove this 20 so that you don't get confused. This is just a separate vector. It's not the P vector, okay? A resultant vector that is in 2D will always have components as well, right? So if you remember our definition, we said a resultant vector is one vector that sort of shows or it represents the effect of all the other vectors combined. So that's why when we find a resultant vector, we first make sure that we combine all the components of the other vectors into one. So first we combine all the x components, like what we're doing here, FPX, FRX, FQX, so that they make up Rx, or Rx will be this side, right? So Rx is in fact a horizontal component of our resultant vector. Then we go back again. We combine all the what's this? The y components of these individual vectors. So we combine the y component of P, the y component of Q, and the y component of R. We get them and they give us what we call Ry. So Ry now is a representative of all these vectors combined, and it is also a vertical component of the resultant vector. Then from there, we can now use Pythagoras by squaring these two and then finding the resultant vector. Right, so that's the idea basically. So what does this tell us as well? It means if I have vector P, vector P is sort of a resultant of its components fpx and fpy. So that's what it means. Vector Q as well is sort of a resultant of its components fqy and fqx. So it is not easy to just add these vectors without first breaking them down into their components, right? Especially if this thing is not at equilibrium. If it was at equilibrium, then it's a separate issue. But it's not easy. That's why we always have to always first break them down so that they are in the same axis, and then we add them together. Then from there, we can then find the resultant vector. I said a mouthful there, but you get the idea.
Yes, sir. Thank you for
All right. I see Innocentia's hand is up. Yes, you can go ahead.
So, since that I don't have the value of my theta, can I say 90 degrees minus 40 and get the value of my theta and use the theta instead of 20 degrees and use the value of my theta instead of 20 degrees? Is it correct?
Let me see. What you're saying is for which vector? For P or Q? Oh, you want?
For
Oh, I see
Q,
what you're saying. For Q, we found theta though. We did what you are saying. We said 90 minus 20 and minus 40. So if you check this, let me remove this. So if you check this, right? If you check that, yeah. Let me use red, blue. So our x and y are perpendicular to each other. So that's why we have a 90 here. So the total angle here is 90, right?
Mm.
So it means if we say 20 plus 40 plus theta, we say 20 plus 40 plus theta, we should get 90 degrees. So since we want theta, we will say theta is equal to 90, and then we transpose everything that side, minus 60. Then yeah, we get 30 degrees. That's what we did, yes. Is that what you're asking?
Yes.
Yes, that's very correct.
Okay. So I can use the value of my theta instead of using the 20 degrees.
20 is for P, but theta is for Q. So you must be careful there.
Okay.
Yeah, so always check these things. So you see this, let me see. Yeah, let's use R for instance. See this line here? This tells you this angle here is for this vector because it's drawn from axis to where this vector is. So coming back to here as well, theta is for, let me remove this line. Theta, this is the x-axis, and the line goes from the x to vector q. So theta belongs to vector q. Then we come here as well. This line, it's drawn from the y-axis to vector p. So 20 degrees belongs to vector p. We can't use 40 because 40 is drawn from one vector to another vector. So we can't use it as our angle to find components. We can only use an angle that is drawn from a set axis. So it's either drawn from y to the vector or from x to the vector. That's it. You understand?
Yes, I understand.
Okay. So you have erased all of these things, but yeah, you'll be fine. So let's do ry now to finish off this. Oh, actually, what answer do you guys find when you punch on your calculator for rx? For this guy, what did you find here? Let me see if I can get my calculator. I get 160.48 newtons. So remember, we can't just leave it here. This thing is a vector, so it needs a direction. So since we chose the right direction as positive and our answer is also positive, then we can be confident that this thing has to be going to the right. Right? Remember what I explained the other day. So yes, that's what you do. Let's go to 2.2.2. Okay, 2.2.2, they're just asking us to add the vertical components. So 2.2.2, we can literally say, let's choose a direction. I like choosing up. You can choose down, doesn't matter. As positive. Right? And then you can say sum of all these will be, let's come and check them. So if we check here, FQY, let me redraw them. FQY and FQ and FPY are both going up, but FRY is going down. So FRY is the negative one. So we have FP. Also, you don't have to, like what, I know who asked this question, but someone asked this. You don't have to write this step and that step. You can jump to this step and this step. So I only write them out so that you get where it all comes from. So you can just jump straight to this one, these two. You'll get your full 2 marks because it's a 2-mark question anyway. So just take note of that. No? Let's do it. We have FPY plus FQ. Okay, my FQ looks weird. Plus, we said FR is negative. FRY. So it's negative because it's opposite to the direction we chose as positive, okay? So now we can say FP. I know that since our X was sine, it means Y is cos. Cos 20. This looks like 200, but it's 20. Plus FQ. FQ was what? Cos. So we make it sine. Sine 30 degrees minus 3, no, not 300, what's this? FR sine 50. Then we can substitute. We have 400 cos 20 to 50 cos 30 degrees minus 300 sine 50. I want to get an answer from you guys. You should be carrying calculators there. What's my answer? Also, you guys said you did this homework. So, yeah, I suppose you got answers. What's my answer? Hello?
I got 362.57.
Okay, is it positive or negative?
Positive.
And then, so what's the direction?
Upwards.
Yes, because why is it upwards?
Sir,
Yes.
I did not get the same answer.
What did you get? Let me see. I didn't even compare with the
I
cos
got
20. What did you get? I just took
I got
Temba's answer.
300.
You got what?
I got 308,04 newtons upward.
Three. This
308.
is 308. Oh, it's not clear. Let me see. 308.04.
Yes.
That's strange. I get this one as well. I'm not sure. Let's compare this. What did you write here? Is this the same? Even the signs, are they the same?
Yes.
That's weird. Check if your calculator is not on radians. It should be in degrees.
Oh, I set sine instead of cos on 250.
Yeah. Wait. I think you are right. Let me see. So no. I think you are correct, but let's see something. So this is FQY. FQY is sine. Yeah, FQY should be sine. FQX is cos. This. Oh, I made a mistake here. FQ 250 sine. Yes, you are right. 30. That's a very, very horrible mistake. So now 300 is FR. FR should be sine. Okay. FR is fine. FQ is fine. FP. FPY. Yeah, everything is fine. So yes, you are right. Innocent chat. I made a mistake. That should be sine.
But when you press the calculator, it gave me 271.06 tons.
Yeah, that's the right one. That's what I get now as well.
Okay.
271.6. Yeah, but everything else is fine. I don't know why I changed from sine to cos here. That was weird. But yeah, that's a weird mistake. All right, so 271.06 upwards, ne?
Yes.
Thank you for noticing that 0.6 newtons upwards. So now, let me double check to make sure we did everything right. For FQ, FPX, we should be saying sine, right? Sine 20. Okay. FQX should be cos. Okay. FRX should be cos. Yeah, everything checks out. Okay. So this is what we get. And now, using the answers to question 2.2.1 and 2.2.2, draw a label vector diagram. Show the resultant force on this diagram. Okay, so let's do it. This is what I've been explaining to you guys. These components, Rx and Ry, they are the horizontal and the vertical components of a resultant vector, respectively. So now, what they are saying is, let's draw a labeled vector diagram showing all of these components, right? And also showing the resultant force on this diagram. So obviously we need to know our directions. So since we said Rx is going to the right, let's start with Rx. This is my Rx. Okay, this thing all of a sudden is Start with Rx. Hope this is not too long. Okay, it is. Just do it there. Good. Now, Rx is to the right. We know that for sure. We also know that Ry is going up. So we can either draw it here or you can draw it there. But let's use this one. Let's use the tail to tail. Ry is going up. Now, remember what I said. The length of the arrows sort of tell us their magnitude. So we know that 160 is lower than 270. So that means the length of the arrow that represents Ry should be longer than the length of the arrow that represents Rx. Why? Because 271 newtons is greater than 160 newtons. And 160 belongs to Rx, while 271 belongs to Ry. So you try to represent that situation even when you're drawing your arrows. So this should be slightly longer than this one. Yes. So this is my Ry. This is my Rx of 271.06 newtons. Let me see if I can say 160 point what? 48. And this is my Ry. Okay, so now we can draw our resultant vector. From the tail of these two guys to where these two lines meet is where our resultant vector will be. They didn't say we should calculate it, but they said we should just draw it. So this is the F resultant, right? So since we were not told whether it should be a closed vector diagram, open vector diagram, tail to tail, and so on, you have two options. You can either draw it like this, right? Or you can use option 2. Will it fit here? I'm not sure. Okay, but I'll draw it slightly. Option 2 says there's vector 1, which is my Rx. There's vector 2, starting from the head of vector 1, which is my Jesus. Okay, I don't know. So redraw this again. If you remember what I was telling you about the tail to head method. So obviously it needs to be such that the tail of the resultant, the resultant vector is drawn from the tail of the first vector, right, to the head of the last vector. So like this. This looks ugly. Yes, much better. So that's our F resultant. Then you can put your theta here. These two diagrams represent the same situation. So you choose which one makes more sense to you. Okay. So yes, this is what they want in 2.3. They didn't ask us to find the resultant vector yet. They just said we should draw a labeled vector diagram. By labeled, they mean each vector you must stipulate, or you must tell us what is it. So going up, we have Ry. Going to the right, we have Rx. And the diagonal one, or the 2D vector one, is our resultant. And then we have our theta, which is the direction of our resultant vector. All right. So let's go to 2.4. Remember, if you don't get it, you are welcome to stop me. Hence, calculate the magnitude and direction of the resultant force. Okay, you see now they want us to find the magnitude and the direction. Let's start with magnitude. Remember what we said. Let me take one of these triangles. Let me take this one. Copy. You won't get marks for drawing a triangle. You can draw it separately though, so that your mindset or your mind knows what you are doing. Remember, we said we just take this triangle. This is always a right angle triangle, always, okay? Then from there, we just use Pythagoras theorem. So what that means is f resultant squared is equals to rx squared plus ry squared. Then we square root both sides, right? That means f resultant is simply rx squared plus, okay, let me use brackets, rx squared. Using brackets is a good habit, by the way, so that when you have a negative sign and you want to put it here, it looks like this, maybe. Yes. But you don't have to use them if you know your maths, I think. So now we have this. What is our ry, rx? We said rx is 160. What is it? 160.48 plus 271.06 squared. Right. So what answer are we getting here? This is my reference.
The answer is 315,00.
0, 0. There's no need for those zeros. Let's just put n here.
Okay.
So yeah, if it's 0.00, you don't need to include them. Unless those numbers are greater than 0, then yeah, you can include those two. So now we have our resultant, but it's not complete. It needs a direction. So let's find our direction. So with the direction, I want you to always know that it'll always be tan theta is ry over rx. Always, okay? So unless, of course, it's some trick exam question where you don't have ry, but you have rx and frs or something like that, and you have to find theta in a different way. But most of the time, or 90% of the time, it'll always be, this is the formula you use to find the direction. So, but if it's a different case, your knowledge of mathematics will save you in that case, okay? It's what I always say. If you don't know your maths, you will not be able to do physics properly. Because you see now we are using Pythagoras theorem. This is not a physics topic. You will never learn about Pythagoras in physics. But you learn about it in maths. And look at us now, we are using it. Okay? Theta is this. Then, I'm just saving space here, guys. We'll have, what is my ry? 271. What is my rx? 160.48. So our answer is what? 271. Let me see.
The answer is 59,37.
37 degrees. Thank you. Guys, please also check our answers. You see, I wouldn't have seen my mistake if you guys were not participating. So thank you for your participation. Also, with these kind of mistakes, notice that I wrote everything correctly here. But when I was coming here, I suddenly changed sign to cos. So the way you limit those mistakes is by practicing. So one of two things will happen the more you practice. One, you will know where are you most likely to make mistakes. And then two, you will sort of be faster in solving these type of problems. So when you know usually it's okay, I usually make mistakes when I start substituting. You will pay more attention there so that you limit those mistakes. Okay, but if you don't practice, you won't know. You make a mistake in an exam and forget about it. Right? You won't even know you made that mistake. So that's one thing I want to raise. Okay, now let's write our full answer now. It means F res is simply newtons, and then our direction is 59.37 degrees. So this is how you write the resultant or the full answer or our resultant vector. Yo, I need a new pen, guys. This thing is not nice. What is this doing? Okay, fine. So this is how you write your final answer of a resultant vector in 2D. Magnitude and direction. If it's missing one of these two things, it is not a vector, it's a scalar. Okay, and we don't do scalars here, we do vectors. All right, so that brings us to an end of this question. And then there's another one that I wanted to show you guys. It's about equilibrium, which is we didn't get a question on equilibrium on our last lesson. I didn't give you a question like that. So let me show you one. Should be enough. Let's see. Do this one. Yeah, this one should suffice. Right. So here's the thing about equilibrium, guys. Whenever stuff is in equilibrium, right, it means one of two things will happen. The resultant force is zero, right? Or if it's an object, what will happen is that object will move at a constant speed or velocity or whatever. It won't, yeah, but that's what it means. Okay. So, excuse me. That's what equilibrium means. So now we have this situation here. Okay. Okay, let's do, yeah. So now we have an object of mass m, right? And then it is attached to string z and hangs vertically downwards at point O, okay? Then they gave us the angles of Q and P. All right, so these are the angles they make with the horizontal. Notice that they are showing you the line at which we are measuring the angle from is a straight line like this. So it's from the x-axis essentially. So we can use this angle to find the components of these two guys of P and Q, right? So that's one thing you must remember. So let's go to our questions. What is meant by forces at equilibrium? All right, it's like what I just said now. Forces at equilibrium means the resultant force or the resultant vector is zero, right? The resultant vector is zero. Or number two, or remember, another name for resultant is net. The net force or the net vector or the resultant force is zero, right? Number two, that object is either at rest or it will be moving at a constant velocity. That's what equilibrium means. Okay. So, but in this case, it just means there's nothing moving here. So this thing is at rest. And then we can say the resultant force is zero. So means the net force is zero. Or you could have said it means the object is at rest or it's not moving. Okay, but for now, let's take this net force one. So that's it, guys. I hope you get that part. Now we have question 3.2. Draw a labeled closed vector diagram of forces showing all the forces acting on point O. Indicate two angles in the diagram. So this is one of the reasons I picked this question, because I remember we covered this in our class, but in theory we didn't do an example on it. So you wouldn't know how to do such questions unless we did it. So 3.2, if you remember a closed vector diagram, guys, it's a vector diagram, it's a triangle usually, right? Where you make sure that all these vectors are connected. You draw them connected in the same order. You don't change the way they are in the diagram. You keep them as they are, but they must form a triangle. You draw them in a triangular format. You can only do a closed vector diagram, and please don't do it for other cases. You can only do it if that system is at equilibrium, or if the net or resultant force is 0. Never in any situation except this situation. So now this one, we know that these forces are at equilibrium, so we can do a net force diagram, right? A closed vector diagram. So in our closed vector diagram, like I said, we will have, you see that I have vector P, ne? Actually, before we do the closed vector diagram, let's draw a free body diagram of this situation. Notice that we have vector P slightly longer than Q. That's P. We have Q somewhere here, slightly shorter than P. Okay, no, this is inaccurate. So let's just do them. Yeah, P, Q. Then you have weight. Some people write it as FG, like this. It's the same thing. So I usually prefer weight, like W, just makes things easy. Right, so you have these three vectors. What we want to do, we have our FBD, free body diagram. Now we want to turn it into a closed vector diagram. So we do it like this. You have all of your forces, by the way, you don't change them. You know that P is going there. This is one side of your triangle. So let me write P here. Right. You know that Q is coming this side like this. And you know that W is going down like this. Okay, I made Q a bit longer. So notice that these are connected very nicely. The tail of P starts from Q. The tail of weight starts from P. So they're all connected. Let me just remove this weird line here. Yeah, better. So you see, this is what you call a closed vector diagram. Now, a closed vector diagram, it doesn't mean that this angle will always be 90. We don't know what it is. So we have to find this, that, or that. It depends. So they said we must make sure that at least two angles, let me see. Oh yeah, two angles in the diagram are labeled. How do we find those angles? Because we know, for instance, we know that P pera is drawn like this. It's 30 here, ne? There was 30 here. Let me try and make it huge so I can label some of these things. If I make it huge, it means my alphabet will be huge as well. Right? It's fine. Okay. So we have that, right? Now, I want you to remember that I said you are not changing anything here. Let me reduce these things. They look big. This is P. You are not changing anything. The initial angle that P had will still keep it. So what that means is here, if you were to draw a line here, this angle is still the one that we are given there, which is 30 degrees. And if you draw another line here at, what is this, Q, this angle is still the same 60 degrees that we were given initially. Nothing changes. Okay? So now, this is where you use your maths now, right? So with maths, typically what you normally use in situations like this is, okay, luckily for this one, we can get this angle easily. Check here. We know that this vector, what is this, W, which is our weight, it's going straight down. And if it's going straight down, and I come and I draw a line here, that line will automatically be perpendicular to, so this line is here, ne? Yo, what is this thing doing? Yes. So this line will be automatically perpendicular to my vector W. So now I already know this angle, right? So how can I find that angle? Can someone tell me? How can I find this angle? Because this is the angle I want so that I complete my diagram. How can I find that angle?
We're going to say 90 degrees minus 60.
Yes, that is very true.
Which is going to be 30 degrees.
Thank you very much. So you're gonna get 30 degrees here as a result. 30 degrees. But they say we must mention two angles in the diagram. So let's find another angle. Either we find this one or we find that one. So, okay, let me erase this so that it doesn't look like a lot. So this angle. Have you guys done sum of opposite interior angles? Okay, I assume you haven't. So now, if you check another thing that's happening here, you have this. Do you remember this thing in mathematics? Where if you have lines like this, think parallel lines, you do this. Please correct me if I'm wrong. I forgot some mathematical things there. Then if these lines are parallel and I happen to draw a line here, right? What will happen is this angle and that angle will be equal, no? So what's stopping me from saying this angle and that angle are the same? So I can get 60 here. Once I get 60 here, clearly this is a 90-degree angle because 60 plus 30 is 90. What that tells me is this has to be 60 degrees too. How did I get that 60? Sum of angles in a triangle. So that is essentially how you would find everything in this angle. So this is how your final diagram would look like. Oh, I erased everything. You would remove this and maybe that, and then it would look like this. This is how your final diagram would look like. The two angles that they wanted and also everything else labeled. That's how you would do it, guys. So luckily for us, it's not always the case, by the way. We're just lucky that this thing is also, it happens to be 90 degrees. And also we didn't know until we started calculating or started relating this angle. But never think that this thing will always be a right angle triangle. In fact, most of the times it is not. So in this situation, they just made our lives easier by making this into 90 degrees. I sent someone as a question. I think someone wanted to ask.
Say, I kind of don't understand the part whereby you said the angle between P and Q was 30 degrees, right?
And
So
Which angle is that? You mean this one?
The diagram between P and Q.
Wait, here.
Yes.
Oh, let me just redraw it. So we had something like this. You mean this angle, no? Yes, you can continue.
So, and between W and Q, yeah, I understand where the 30 degrees comes from, but I kind of don't understand where the 60 degrees comes from between W and P.
Oh, okay, no stress. Let's do that fast. So what we said is, remember, you understand this part, this one. Do you understand this one?
Yes.
Alternate angles. Okay, good. So remember what we said. We said, let me write them in red. We will get that this one was already 16. You remember that we didn't make it up. We took it
Yes.
from our diagram. So I was saying that this and that these are alternate angles. I can get a 60 here. And at that point, we didn't know this 16.
You didn't know it.
Yes, we didn't know it at that point. So what I'm saying to you is, remember that rule that says sum, I think you usually write it like this, sum of angles in a triangle should give us 180.
Yes.
Right? So if I come and I say, let's call these, let me name these sides. Let me call this side angle A, angle B, and angle C. What it means is, if I say A plus B plus C, I should get 180 degrees. Okay? Do you get this part? Yes.
Yes.
So angle A is the one I'm looking for. I don't know it. So A plus B is 30 plus 60, plus 60. It's this one. It's this whole thing. That's B. Remember, we're taking this triangle now.
Made
We're taking
angle 90 degrees.
A.
You made angle B equal to 90 degrees.
I didn't make it 90. It is 90 when we sum them.
Okay.
Yeah, but you can think of it like that. I didn't make it 90 though. But this B, because if you check, like what I was drawing here, this is my triangle. This whole thing. So I have three angles in a triangle. I have angle 1, right? I have angle
Yes.
2, right? And I have angle 3. You agree? Do you agree?
Yes, I agree.
Yes. So now I'm adding all these three angles, and it just so happens that B is divided into 2. But in actual fact, it's one angle. And when I add them both, they just give me 90. I didn't make them 90. They just happen to be 90. I didn't even know they were going to be 90. Okay?
Okay.
Yes. And then now we have angle C, which is 30 degrees. And this gives us 180. So what happens here is A, and I add everything this side, I'll get 120. Because this will be 90 degrees plus 30. That's surely 120. It's like 9 plus 3 is 12. So now I can solve for A. A is 180 minus 120. Because I transpose, then I get 60 degrees. So this is where I found that 60 degrees. Do you get it? Hello?
Yes, I do get it.
Okay. Awesome. So now that you get it, let's continue. I think this will be our last question. And then if you guys have more that you would like us to cover, you're allowed to tell me on the group. We will do it. Oh, why am I removing all of this? We will do them, but this example is literally the last example that I will use to show you how the theory that we have learned, you can translate them into solving these problems. Okay. You can do more for practice. I'll give you another homework. I think I have another equilibrium example. I'll give it to you, then you guys try it out. But for this lesson, this should be, because we have to end at 8:05. So now we are told that the tension in string P, so this guy, let me actually write it, is 50 newtons, or newtons, as some people would say. And then calculate 3.3.1, calculate the tension in string Q. Okay, let me show you how we can use this triangle we just drew now. Okay, I won't draw the arrows now, but what we essentially have now is, we said we have, let me just draw it as a simple, because it's a right angle triangle anyway. So we'll have this. Yeah. My pen is doing funny things. We have this line. Okay. Why is this thing not straight? Bear with me, guys. Let's see. Great. Okay, I'll leave it like that. And then that. I'll just draw it like this. It's taking forever. So it has an side like this. Then this is W. I think what else is there? Or should I just take it as it is? Yeah, it's fine. Let me take it as it is. Take this whole thing. We can turn this into 90. Right. Okay, it's fine. And turn this into 90. Okay, so now let's check. Let's do what the question is asking. This is our Q. We are told that vector P is 50 newtons. Okay. And then now they are asking us to find the tension in string Q. So you can do one of two things here. Either you can use this closed vector diagram, or you can just use the fact that this thing is at equilibrium, right? But since we already drew this vector diagram, let's use it, okay? Okay. So if you remember, what I said is math or mathematics will always come in handy. So here, if you want, you can use what's called the sine rule, because you have one side and you know most of the angles and you are looking for this side. Or you can use, let's see if you can use trig ratios. Okay, trig ratio is not a good idea. Oh, it is a good idea. Yes, you can simply say tan, I'm sure you guys will agree with me, tan 30. Remember, tan is opposite over adjacent. Okay, and then you can have 50 over q. You don't know what q is, right? And then you can say 50, not 50, sorry. You can just cross multiply. You guys know how to cross multiply, right? From math. It's unfortunate I can't teach you maths basics, but they are very helpful in physics. Q is the same as 50 over tan 30 degrees. You will get that by cross multiplying. So what answer do you get here? 50 over tan 30. So that's 3.3.1.
Got 86,6.
6, just like that. No, nothing else after the 6.
0.
Oh, 6, 0, okay. This is newtons, okay? So, yes, that's what. They didn't ask us to find the direction, so we can leave it at just that. But we know that it is at 60 degrees, right? In case, because it's a vector, I don't think it's a good idea to just leave it without a direction. In fact, it's not a good idea. So let's write our 60. We already knew that it was at a 60-degree direction, okay? So we will write our 60 degrees. So are you guys happy with this method, what I just did here? There's also a second method that you can use. Usually that one will work if you can't get this vector diagram, but I doubt you would struggle with that. So what that method entails is, it's a bit longer though. You would have to group, let me see. Yeah, that one is a bit long. But essentially what you would do is, remember, Q will have a component FQ, FQY, and then it will have another component FQX, ne? Same as P. P will have FPY and then FPX, right? This is another trick you can use. So what equilibrium tells us, guys, is these components, they must be equal to each other so that the net force is 0. Okay, what does that mean? It means FQX must be equal to FPX. And also it means, remember, these are all the horizontal components. They must be equal to each other. It means that W, which is my weight, should also be equal to FQY plus FPY. Right. So that's what equilibrium means as well, mathematically. So what that, in case this is confusing you, how we got here, sorry guys, sometimes I skip steps. So how we got here is, we said sum of forces in the X, ne, is equals to 0. That's what equilibrium is saying. And also sum of forces in the Y is equals to 0. Then obviously you must always choose a direction. So this is method 2 that you could have used here. So this method would be very helpful to you if, let's say, you realize that I don't know how to draw this closed vector diagram and I have forgotten. This one, it will work as well. We just don't have time to prove, but let's see. Let me see, what's the next question? Next question, mass of the object. That's fine. Let's do this method 2 and see if it works. So let's call it method 2. Right, so with method 2, remember what I said. You would say sum of forces in the X is equal to 0, ne? We are choosing a direction as that one. Right is positive. So what are all the Fx components? It's Fpx and Fqx. But Fpx is negative because it's going opposite to what we chose as the positive direction. Okay? So let's do it. So we'll have Fqx being the positive guy, and then we'll have minus Fpx equals to 0. So now you see where that thing I was telling you about comes from, this whole Fp being equals to Fqx. Because when I transpose this that side, it becomes positive, right? And then you get something like this. From here, you would be able to find your Q, because you would say Fqx is simply Fq. I think it's cos. Let's see. Yeah, it's cos because we have a 60 here. Is it? Yeah. Yes. Yeah. So we'd have cos 60 equals to fpx will simply be 50 because we are given this one. Let's go check if it's cos or sine. It's also cos, but cos 30 in this case. Cos 30 degrees. Do you see? Even this one works. You can say divide by cos 60. Divide by cos 60. Yeah, it should work. I find it weird that... Oh, okay, it's fine. So, 50 cos 30 over cos 60. We get 86.60 newtons. That's FQ. Let's see if it's the same. Oh yeah, so check, it's the same thing, né? We get the same answer. So the principle works, okay? So that's one thing I want you to take away today, guys. Whenever things are at equilibrium, it means even when you sum these forces, but only when you sum forces along X and along Y, for now, because you are in grade 11, okay? If you sum all forces along Y, you must get a 0. If you sum all forces along X, you must also get a 0, right? So you will choose the equation that gives you the quickest answer. In our case, fx was going to work. Let me see, fy could have worked, but it was going to take a bit longer. Okay, so it works. So both methods work, okay? So now how do we find the mass of this object? 3.3.2. I think that one I can leave it to you guys. Maybe you can tell me how we can find the mass. We are asked to find the mass of the object. How can we do that? Finding the mass. There are also two methods for this one. Let me see, you can use... Yeah, I can use trig ratios, or you can use... Guys, remember, a right angle triangle, if you have A, B, and C, C is simply A squared plus B squared. You remember this, right? If you have a triangle like this. Okay. So what does this mean for us? It means I know that I have a right angle triangle here. And mind you, this would be my A. Oh, this looks like a weird A. Let's do it. This would be my A. This would be my B. This would be my C. So it means I can say W squared should be, oh, let me just use the final one. W should be P squared plus Q squared. Do you guys agree? Because it's A squared plus B squared. If you are confused, you are welcome to stop me. So yeah, when you're quiet, I know you are fine. Or you are confused, but you don't know how to ask, I don't know. So far, you've been asking, so I assume you are comfortable with asking. So what we can do here, we know that this is weight, right? And weight, remember that weight is simply mass times gravity or gravitational acceleration. So we can bring that here, mg. And then we can come back there and have, what's my answer? It's P is 50 squared, I think, plus this one is 86.60 squared, right? Then that's my m times 9.8 because g is 9.8. Or I can simply just divide both sides by g. Then my m would simply be 50 squared, 86.60 squared, all this over 9.8. So this is how I find my mass. It's just one of the ways you can use to find mass. Or you can use trig ratios. It's up to you. So 50 squared plus 86.60 squared over 9.8. I get that this thing is 10.2 kilograms. 20. Yes. So this brings us to guys, please ask if you are confused. But that brings us to the close or the end of this lesson. Oh, that's 3.4. Sorry. In which of the strings P, Q, or Z will the tension be greatest? Give a reason for your answer. P, Q, or Z. Let's see. Oh, you can calculate. Okay, we already know Q. Q was 86, is it? And then, but by looking at it, it would have to be Q. Yes, it would have to be Q. Because it's already 86, is it? Let's see. Let's just calculate. Yes, I think Q is the right one. Mainly because Q has a bigger angle. So my logic says if Q has a bigger angle, it means its components, since its components must still make sure that this thing is at equilibrium. So since it has a bigger angle, it will likely have smaller components. So it had to compensate for that, it will have to have a larger tension. But that's just my logic. But if we calculate it, I think we might find that Z will have the highest tension. Yes, yeah, that makes sense because 10.2 times 9.8 is around 90 something. Yeah, so Z will have the highest. Why? Because the weight felt by the string will be, it's 90, I get 99 newtons. So W is 99, Q is 86, while P is 50. So we can't use this because this is the weight. We know for sure that these are the tensions. So yes, the answer is Q. Yeah, we can't use the weight because that's not let's see, to a string. Oh, Z is part of it. Sorry guys. It'll have to be Z then, which is Q, sorry. I mean W. Yeah, because clearly it has the highest magnitude, so it has the highest tension as well. But yes, guys, that's the end of our lesson for today. I think if you have more questions, please feel free to share them on the group. Or if you are stuck on your homework problem or whatever, just share it on the group. Then we will be able to assist you. All right. We can log off now. I'll see you on the next lesson.